and for other people trying to debug your code, right? And commenting and documentation. So commenting and documentation, it's a reminder to you guys and a reminder to myself as well, because I need to write more comments and documentation. But things that are obvious to you are not obvious to others. And I'm going to be repeating this multiple times during the presentation because this is so important, and I need to do it more myself. So yeah, just write more comments and documentations, right? And package management. I didn't realize how important this would be when I actually went into the real world of software engineering. I took it as granted that we could just upgrade packages willy-nilly and it'll be fine, and just managing dependencies would be really easy. But no, you can actually mess this up as well. So whatever like package management thing you're using, like pip or npm or like I think Gradle for Java, just do this more consciously, right? And the next are shell scripts and make files. So you will be working with the terminal a lot, like Linux commands, and you'll be writing a tons of things to format your code, things to spin up Docker containers, and things to spin up your server in your local host or whatever. And these commands can get quite long and quite repetitive to type out like again and again. And you can also always make mistakes and all that. And these shell scripts, they're just these commands that you can like write in a .sh file, and you can run them again and again. So it just makes life easier. So you don't have to type everything again and again every single time, right? And finally, second last is IDE features, right? So IDEs, they have more uses than just writing like pretty colored code in a dark background. They have a lot of useful features if you just really dig into them. So use it for debugging. Debugging your code is a lifesaver when you're trying to find bugs, because really it is literally the name. Because the code will not exactly do what you want it to do when you're writing code that is rushed, because you need to make a deadline. So yeah, it is really worth just going line by line and just checking if your code is really doing what you intended to do. Refactoring. A lot of editors have like useful refactoring features. Let's say you want to change a class name to something else, and you want to change it all at the same time so that all these important dependencies don't get messed up, and the IDE can do that for you, right? And just like getting test code coverage, that as well, that can also be useful. There are packages that give you test code coverage in various languages, but when the IDE does it, it can highlight like which parts of the code are tested and not in the IDE itself, like through like pretty colors, So it is useful like that. So it is worth like just going into depth about the IDE features, because they do really make your life better as a developer. And the final is CI/CD, and Beach did a whole like workshop on this, and and for people who don't know, CI/CD is short for continuous integration and continuous deployment. So continuous integration is like whenever you make a PR, the CI runs, and it just checks the code for if it has any linting errors or like typing errors, blah blah blah, and like testing. It runs all the tests to make sure it all passes. Oh, question.
What's a PR?
PR. Oh, pull request. Right. You'll be working with source control most likely in any form, but usually GitHub. And a pull request is saying, hey, I made changes to this code. Can you pull this into the main branch? This is a request you're making, right? And this CI, it ensures that all of the code getting merged into the main branch is of a certain quality, and this makes sure that whatever code code changes you're making is good enough, right? It strictly enforces it. We can't rely on people to not make mistakes. So you automate it. And CD, continuous deployment, is when you actually have to deploy your code into a production or like dev server. You can do it manually. You can like SSH into a remote server and just like git clone and then like Docker up. But that's just takes too much time, and just as usual, because people do it, it is prone to error. So because we're developers, you automate it, right? And that's a big whole topic in itself. And there's like a job, like a DevOps person that just does this thing as their like whole job, and we have a workshop for that, so you should check it out. Yeah. Tell me if I'm going too fast. All right. Next is people. So yeah, people. So it may come to a surprise to some developers, but developers have to talk a lot. It's not a job where you just only stay in like a cubicle and code for 8 hours a day. That sometimes happens, but most of the time you have to talk to other developers and you have to talk to PMs or POs, whatever you have at the company, or I guess in Korean terms like 기획자, you have to talk to them, right? And since our communication mostly deals with internal stakeholders, like people within the company, I think it makes our job a little bit more difficult, right? If you're like an outbound facing person and you're dealing with a lot of customers, if you mess up with one customer, that customer will go away, right? And you can try to do better with a new customer. But with internal stakeholders, you need to see them every single day. Hello. So that just remember that if you piss someone off, they will remember. They will remember how you made them feel, and you will face the consequences, you'll have to see them tomorrow, next week, next month, next year, unless you quit or they quit. So if you fuck around, you will definitely find out, right? So, yeah, the short and long of this, I'm going to go into more detail, is be nice. It is difficult, and I'm reminding myself as well as others, but be nice, all right? And so to go into more detail of the topics that I have here is when talking to developers, right? Google first, try to solve the problem second, and then ask third, right? And that is very, very important because personally, I experienced when people did not Google first or ask second, they just immediately asked questions, and asking questions is fine, and because we have to just solve the problem. If you're like stuck with a problem for 8 hours or like 2 days or 3 days, that is just really inefficient use of your time. So do ask questions, but make sure that but when you ask a question that you have actually tried it yourself. All right. So, and because asking questions is like a costly thing, right? Because as knowledge workers, we need to be in a flow state to write good code, and asking questions can like break us out of that flow state, and so that that can be costly. Just have that in mind, right? But that doesn't mean we shouldn't ask questions, all right? So the next is like saying no. You're gonna get lots of requests to do features or bug fixes or whatever. You need to learn when to say yes and when to say no. And because if you really just say yes to every request, you're gonna burn out. You can't do everything. I've seen people burn out. I've burned out myself by saying yes to a lot of requests. And if you burn out, you will write sloppy code, and it will just cause more errors. Just like don't do that. And the next is asking why. When a PM or a PO comes with like this feature, you need to ask, instead of just saying yes immediately, you need to also ask them why this feature is needed, and like just grill them if this is really actually necessary, because they may be coming up with like some half-baked idea, right? And it will be a waste of time to just do it. And as developers, you're gonna have like a huge backlog of things to do, things that you could be like improving, and not always just like adding new things. Question?
How huge is huge?
That's going to depend on the company, but I think that the last company I worked at, we had at least like 10 or 20 things that we wanted to do, but we couldn't do because we had no time.
That's it?
I mean, like, these are 10 or 20 big things that we wanted to do.
Oh, I see, okay.
Yeah. And the next is over communicating. This is something that I forget to do all the time, because what is obvious to me is not going to be obvious to the other person, and vice versa. So for example, at the new company I'm at, I wanted to implement end-to-end testing because there wasn't any testing, and I thought that end-to-end testing would be the most efficient way to cover a lot of test cases and use cases most efficiently. And an end-to-end test to me is just simulating an API call through a test client and going through the client, through the service layer, and into the persistent layer, the database, and just going up and down, back again a lot of times for every use case. But the guy I was talking to, he thought that end-to-end testing meant just stress testing. So like like 10,000 like 200,000 like calls at an API to make sure that the API can like handle all that load. So we were going back and forth for a while, and then I just realized, wait, what is he talking about? I'm not talking about that. And then when we clarified what we're actually talking about, we just came to a conclusion that yes, we need both. So it just like be very, very obvious. That is really difficult, and just ask yourself, am I being obvious enough? And the answer is usually no. And I also think I'm not being obvious enough in this presentation as well. So I will try to be more obvious. All right. So let me look at my notes again. So yeah, under promise and over deliver. As junior devs, we have very poor ability to judge how productive we can be and whether that we can do certain tasks or not. So it is much safer to under promise, saying, hey, I don't think I can actually do all this. Can you like cut the scope a little bit, right? That's saying yes, but with a caveat, and that's totally fine. You're a junior dev, and if these people are reasonable, they will, say that's fine. And you can just really, and when you say that you're going to do something, just actually do it so that you can build trust, right? And that when you work with people, internal stakeholders, it's good to build a lot of trust with them. Don't be that guy that says, hey, I can do all this, but then really come up with just a little bit and just like producing such little, and that's just you're gonna build like a poor reputation, and you just don't want to do that if you're going to be working with these people for a long time, hopefully a long time, right? And one thing that we could fall into is just being mean to non-tech people because they can't code and they don't understand tech, because they come to us with ridiculous requests at times. So we can be mean to them. Don't be mean. These are the guys that are really at the front lines dealing with all these customers and all these guys, all this kind of bullshit, and just fending them off. Just be nice to them, and just be nice in general. I am trying really, really hard every single day to be nice. And it is tiring, but it is worth it. I have tried to not being nice once. It was torturous, right? But when I switched over, when I went to a new company, and when I was like constantly positive and nice, I left that company on very good terms. I still talk to the people in the previous company, and we're still like friends, So just be nice. But if you don't believe me, just be mean. See what happens to you. I don't care, right? Right. So the other one is just separating yourself from your ideas and code. As a junior dev, if you go to a company, I hope there are code reviews, and I hope there are people that will give you feedback. If not, sucks to be you, I'm sorry. But like when you get feedback on your ideas, on your code, it's gonna sting. It is definitely gonna sting. And for me, it stung too when I got my first code review at my first part-time job. But when I really fully accepted those feedback and those stuff, I really grew as a programmer, because I really began to see all the problematic ways that I've been writing my code. And when I just separated myself from my code and my ideas, I just really could see myself improving like day by day as I was writing code. So yeah, as a junior, one of the best things that you can do is just separating yourself from your ideas and code so that you can accept feedback better and grow better, right? And the final thing is automate. Oh, question.
So when you say separate yourself from your ideas and
Yeah.
code, so like, I don't really understand.
Okay, so let's say you came up with an idea, let's do X. And I could say, hey, I think that's shit. I'm saying the idea is shit, but you're not shit. I'm criticizing your idea, but I'm not criticizing you. So you shouldn't feel bad. Yeah, don't take it personally, is what it means. Yes.
So can I jump in?
Yes.
So like, if I say like, hey, I didn't have an example right. Crap. Basically, when you've built something, right? Like, naturally, we're invested in it, right? I put effort into this. I expressed myself through building this. This is the result of my thoughts and my effort, and you end up developing this sense of ownership with that thing. And it's natural, right? And in some cases, it can be good. Like, if you're raising a family and like children, you want that kind of thing, right? But you don't want that when it comes to code, right? You want to not feel like it's your code, like you own it, that you're invested in it. It's just text. It's just a bunch of text. And if you kind of divest yourself, basically, eliminate your personal investment in the code, it's easier to accept feedback. It just feels like, you know, if you just throw some rice in the rice cooker, right? Like that's not effort, right? It's not, you're not personally invested in how the rice turned out. So if someone says, hey, if you just add a little bit more water, it'll be better, you'd be like, oh yeah, okay, maybe I'll try adding more water, right? And so if you don't feel like it's a big deal, then it's easier to accept feedback. Whereas if you feel like you're personally invested in that code that you wrote is like a part of your identity, it's going to hurt. And you want to avoid that. Because what ends up happening, there's actually someone on a team I was on in the past who was very strongly invested in their code, and anytime they got feedback, they were like, but this is better. And it's like, no, here's proof of why this is going to cause problems down the line. And they had a really hard time accepting feedback. They had a hard time growing. And eventually I just stopped giving them any kind of difficult work because I was like, they're not going to be able to do it. They're not going to become a better engineer. I'm not going to invest in this person anymore. Does that make sense?
Yes, you should talk like Beach, not like me. Yes, good job. Thank you.
Sorry.
The next thing is automate. And this just means a lot, I guess, to me. You can end up doing a menial task because someone asked something of you, which is kind of high impact because, you know, it saves a lot of time, but not really, because someone asked you to do it and it's just like, it doesn't really do much. It's just really, really time consuming and you just do it just because you're nice and whatever, right? And you can work really, really hard at it and all that kind of stuff just to be nice to the other person, and it can really end up going nowhere. An example of this would be when a salesperson goes to the engineer and say, hey, I need the sales numbers. Can you write an SQL query for me to query the database and all that kind of stuff? And the query takes ages to write and ages to run. So you're spending at least like 20, 30 minutes a day just kind of like dicking around doing this for the salesperson. You're being nice, yes, but is this really achieving anything? The answer is most likely no. So you should really find opportunities like this and try to automate them, like make it a part of the actual feature of the product, or like just say no, right? I don't have time to do this because you have like, you're a developer, you're like paid to write code, push features, do bug fixes, this kind of stuff. I don't want to say it's too good for you, but it's like, there are better ways to solve this problem than just doing like this manual work. Like this was a mistake that I made in my first job. I thought that, just being really good at this like specific thing would, it would be appreciated and all that kind of stuff. And I spent way too long trying to get all perfect, and really it didn't amount to much, right? So yeah. And the next one is testing. So thankfully, this is another topic that BH did a big workshop on. So there is the link to the workshop in the slides. And so yeah, I can't really stress enough the importance of testing. And what testing means to you as a developer is gonna really vary by person to person, because as BH said, not all experience is the same. So when I talk about testing, I think about end-to-end testing. Through the stuff we did in the workshop, like through PyTest, and like integration testing or unit testing. And those words can mean different things to you. But for me, testing is a way to save a lot of time, right? So when you normally like test your server or your client, you can just spin up like the local host on your like local computer, and you can use Postman or whatever to send like API requests and whatever. And if you think about it, that takes like at least 5 minutes for one request. And then afterwards, you need to type in a new JSON, then you send it again. That takes like 10 seconds to do. A well-written test code can do, I think, around, in my last job, we did 290 tests in like 16 seconds. And for a much faster one, it was 500 tests in like 9 seconds, right? And no human can go as fast as that. It is just much more efficient than what we are used to doing normally. And when I really learned that, I really embrace testing, and when we can do testing as fast as that, it is much easier to find that the code we write will not break anything else, right? Enterprise systems, as you go larger and larger, like small changes that you can make is going to have could have a lot of like cascading side effects, and you don't have time to do like 8-hour long tests where you do 10 test cases for each API you made, or like 10 different use cases for like each like UI page. Like you don't have time for that, so you should definitely automate it, right? So yeah, it really just saves you a lot of time in the long run because it prevents you from pushing bugs into production as well if you integrate CI/CD as well. Because whenever there's like test failure, the CI like throws up an error and prevents you from merging code into main. And if you put buddy code into main, you'll have to like there's a QA guy that will come to you and say, hey, there's a bug here, and then which API is it? What were the inputs? And then you try to recreate it yourself, but it doesn't work. And then you try again, and then it ends up working, and then you have to diagnose the code, and blah 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 blah. It's a waste of time, right? Testing saves a lot of time, so please do it. Okay. Okay, I'm like getting out of breath because I'm like yeah.
It's not a race.
It's not a race. Yes.
It's also like when you describe new concepts to people.
Yes.
It takes time for them to
Yes.
parse the words you said, break down the ideas,
Yep.
and then internalize it.
Yeah.
You're good.
Slow. All right. All right. Another thing is that what the testing makes you do is you become like the first user of the new feature or like the new code that you write, and when you're writing it, it all makes perfect sense to you, and then when you actually start using it through tests, you start to go, hey, why does it need to take like 50 different arguments, and why does this like external dependency, why do we need this? And like all these other things that make testing difficult. This is kind of like abstract kind of stuff that is a bit difficult to just explain without examples. But let's say that your test code, that your API, that the thing you do, it saves things to a database, but it also like saves things to a Google Sheet, right? And this Google Sheets thing, and this API that you want to test, since it does two things. How are you going to test it reliably without having to make like a new Google Sheet every single time to like properly test if that thing actually works, right? And this you can like find a way to abstract away this like Google Sheets interaction thing, and just like go, hey, I'm just going to write a test case where this Google Sheets writing thing is always successful, and just and you can do that if the code you write is loosely coupled. Okay, I'm introducing a lot of different concepts here that you may not understand, but good testable code is code that's written in isolation that doesn't really interact with other different things, right? Because you only want to really test one thing if one thing really works really well. And when you have that in mind as you write code, you will write code that is more like modular and atomic, right? If what's your code to be like that. Yes, question?
What's an example of testing that you've done?
So, testing. Okay. Question?
You want me to give it a shot?
Yes, thank you.
Let me get the mic so that it gets on the stream.
Yeah.
So first off,
Hello, there we go. Okay. So first off, is anyone not familiar with what an API is? Everyone here knows what an API is? Awesome, okay, great. So let's say that I'm writing some authentication service, right? And part of this authentication service, maybe I have one API endpoint to do login, right? So to this endpoint, you send a username, you send a password, and then it goes and checks the database. And then if the username and password matches what's in the database, then you say login was successful, here's some information or an authentication token or something, right? So here's an example endpoint. This is something you might test. You might write a test that, sets up the server, sets up some user in the database with the username and password, and then makes a request to the server with that username and password, and then expects a correct response. Or maybe you're simulating a failure response. You may want to test both, right? And so you would write, if maybe you're writing the server as your main application code that you're building, but your test you would write as a client to make a request to that server at that endpoint and verify you get the correct output. So go ahead.
You can auto-produce it. You can generate fake data. Yes, you can do that. Yeah. So to go into a little bit more detail, what Beach said, like testing setup, you make sure that the server is up. You make sure that the database connection is up. You can populate the database with fake data, and then you can let's test the get API, and then you call the get API, and then you get a response, a 200 OK response, and a response.json with the data in it. And then you can verify that the response is a 200 OK response, and the data is something meaningful, right? And you can also test like a failure response, like a 401. And these are status codes. 200 is usually OK. It means OK, everything's fine. And 401 means that what you're trying to find is not found by the server. And these are like HTTP status response codes. The next thing about testing, which I found really useful, is it makes refactoring just a lot easier. In a lot of cases, the code that you may see in just real life is not ideal code because we need to meet a deadline and just people rush and write bad code. That happens all the time. That happens. And you may come up to a point and say, hey, let's fix this code because this code is just really difficult to work with. And if you don't have tests in place, how are you going to verify quickly that the code that you rewrote is going to work the way you think it should, right? You can just obviously spin up a server locally and just test one by one, but really big changes like that, you just want to make sure that everything is okay, and tests allow you to do that. If you have like a robust test, testing like a framework, and a bunch of tests, right? And personally, even as a junior, with that in place, I was able to refactor a lot of things very safely and just really improve the code base. So yeah, if you want to make improvements to a code base, please have tests first. And finally, is that tests can become documentation on how to use the API or like method or class. When we test, we usually test several different successful cases and several different unsuccessful cases. And these unsuccessful cases are just like, stuff like raising errors, right? And when we write methods or classes or whatever, they are obviously obvious to us, the people who wrote it, but for other people it may not. So we can actually like stimulate the use by writing several successful test cases and several unsuccessful test cases, and we can put that into code and let people know, hey, these are like the good ways of using my method or class, and these are the bad ways of using my method or class, right? And it can even be useful to us in the future when we just go back to our code and say, oh, I forgot everything. I could probably look at the test cases to see what this code actually does. So yeah. And since BH did a whole workshop on this, please have a look as well. So yeah. Questions? All right. The next is architecture patterns. And what does this mean? But first, let me sort of like explain what the usual experience would be for newbies trying to get into software engineering. You will go to YouTube or Udemy. You will start a course, and since they are explaining the very first concepts of what a server or a client would be, and just writing and you will end up writing very simple code that does something very simple. That kind of code is really not good for enterprise architecture, because the problems that we're trying to solve at enterprise level just becomes very complex, and if we go into more detail, that would be a breaching NDA, a non-disclosure agreement, so we can't really do that. I don't think even Beach can really say much more, but let's just say that business logic gets really complex, really fast, and a simple code base can't really handle that. And that's what happens to a lot of companies, and there's a lot of big balls of muds and just spaghetti code everywhere. And as you work with more code like that, it just becomes torturous to work with, because there's codes duplication and logic duplication everywhere. One change here can cause another change there, and just one fix there can cause another thing to be broken. So it becomes a nightmare to work with. Since we have a team of developers working on code, all writing different coding styles and all that kind of stuff, and all following different principles of this is the best way to write code. It does also offer an organizational problem as well, like people saying like this way is better, that way is better, and just the code becomes a mess. And if you haven't experienced it, I'm jealous of you, or just like you haven't been into the industry yet. You will most likely experience this. And this architecture pattern stuff, it is a way to solve both like a technical and like an organizational problem, right? They set rules for where the code should go and what functions that the code should do, so that really people don't need to argue or think about what to do when they write code. And just it also solves all the technical problems of like code coupling and cohesion, which is, I shouldn't have said those words because they're just new things that I should explain. But really, yeah. So these architecture patterns, you don't need to reinvent the wheel. They already exist. They are online, and there are lots of books on this topic, and people have many opinions. Some of those example like architecture patterns would be MVC, model view controller, hexagonal pattern, ports and adapters, clean architecture. All this kind of stuff is already out there. You just need to learn and apply them, or you can just use a framework, right? You don't need to think. Just use the framework. Don't think. Just use, right? So examples are Spring, .NET, Rails, Next, Nux, and Angular for front end. And yeah, and like a benefit to you specifically of using these like architectural patterns are, I think, mainly 4 things, right? Let's say you're at a new company, you onboard, and they're using Spring. They can just point you to the website or a couple of books, and you can be up to speed pretty reasonably well, because there's just good documentation and good examples of how to write the code and what to do when you want to make a new API and all that kind of stuff. But if you go to a company where it's a big ball of mud, this one guy who probably wrote it has to sit down with you and then transfer all his knowledge to you, and you may only get like 10% of it. And compared to the person who's going to be working with Spring, you are going to be screwed, because like you have no idea what to do, right? And that's just like, it solves the problem of onboarding, right? The second is handoff. You're going to have to explain your work to somebody else so that they can do it, so that you can do something else. Either because you're leaving the company, or you're doing something else, or just, or just for like career progression, or you're getting like promoted or whatever. And if it's a big ball of mud, you're gonna have to be the guy that explains like a whole bunch of tribal knowledge and business logic and code stuff all at the same time to this new person who probably won't get it. And he will probably like come to you with a bunch of questions because they can't do the job very well. But like a well-architected code base, where it's like everything is like logically in place, you can just point to like these 2-3 places and say, hey, this part is the API layer. It handles all of the communication with the client. This is the service layer where all the business logic is located, and this is the data layer. This is the data layer where all the communication with the database happens. And when you want to make a new API, you can touch these 3 things and then write a test, and you'll be fine, right? But if it's not like that, then well, good luck to you. The next is just productivity. The good thing about like all these like the Spring, .NET, Rails, Django, blah blah blah, is that you don't really need to think too hard about the technical stuff, right? All of the frameworks just do it for you. You just have to fill in the blanks with the business logic that you're trying to solve. And when you're rushing, because the PM is making you rush, saying, "Oh, the client needs this by next week," it's okay for you to rush because the guardrails are already there. You just need to fill in the blanks with the business logic, right? So that just makes things much easier for you as a developer, right? And finally is no one point of failure in terms of like in terms of technically and organizationally. Usually in a big ball of mud, usually one guy wrote the entire thing, and if that guy's gone, you're screwed because nobody knows how to work with the code base, and you're all just working overnight trying to figure out what the hell is going on when there's a bug, and it'll just be bad for you. And just like technically, in a big ball of mud, if one thing fails, a whole bunch of other things can fail, and you're going to spend a lot of time trying to figure that out because the code is just all over the place, right? and that just make things just difficult for you as an engineer and as a person. So yeah, this is why just architecture patterns are worth to learn and are worth like applying to your job. And applying to your job is going to be difficult because you have to reach a consensus with everyone else, and that's going to be helpful if you're nice to everyone. And you're going to have to like test the code to see if it works, and it's going to be useful if you have a lot of test cases covering a lot of like use cases, so that what you fixed actually works. So yeah, if you were nice to people, if you have a lot of tests, applying these would be very easy. Next slide. So all this kind of stuff will make you think, what companies have all this kind of stuff? How do you find out? You find out during the interview. So congratulations, you passed the resume review and the code test and whatever kind of stuff, and you kind of like went through the interview, and they asked you, hey, do you have any questions for us? And that's when you bring out all these questions, right? So you have to grill the interviewers, right? You have to like make them prove to you that their company is good, right? Just don't settle for bad stuff. Don't sell yourself short. Just make sure that the place that you'll be spending like 8 hours a day for like 5 days a week is actually a good place to be in. So really grill your interviewers. And so each link that I have in this slide that I put here are like GitHub repositories where they have a lot of like questions that you can ask your interviewers. And from these like questions these are the kind of stuff that I actually just asked my most current company. And yeah, after asking all these questions, I thought that it would be worth joining them. You can ask them like technical stuff, like what's their testing policy is and all that kind of stuff. What's their CI/CD pipeline? How long does it take to deploy? Blah blah blah. And you can ask them how the project management is, because your life as a developer is going to be really just swayed by the quality of the PMs that you work with, unfortunately.
Can I add something?
Yes.
So also as a hiring manager, if a candidate starts asking this stuff, it's like, hey, this person actually thought this job through. They're thinking about like how they'd actually do the work. I want that guy. So very good questions to ask in an interview.
Yes.
Most candidates that ask these questions in interviews I've done do quite well.
So yeah, bad companies, they will start to sweat, you know. So if you start asking these questions, and it feels really good to be the person saying no to the company when the company says no to you a lot. Like, I have the power now, you know. So congratulations, you got the job. Now what? You're going to be writing code and all that, but you're also going to be learning a lot. You're just going to be learning a lot just by being around developers and talking to them. All of the stuff that I learned about like CI, you know, developer productivity and all this kind of stuff, I just learned on the job. But like, what about more? You know, if you're self-taught or boot camp or whatever, they mostly teach you stuff that's really just gets you ready for work and not much else. And you don't know where to find all this other kind of stuff. So where? So the TLDR is where you find them in books. Two, you study computer science. And why? Is so that you can solve like difficult problems. And I'm going to elaborate more. A lot of the beginner stuff is in YouTube and Udemy because it's very, very accessible to a lot of different people. But like the more difficult stuff are in books. And most of the time they're like thick college textbooks that are like 500, 600 pages or more and just like really dense. Not a lot of pictures to look at, and it's just a chore to read after work because you're just so tired. You just want to rest, right? So what do? You go for the easier stuff, right? There are middle school and high school computer science courses. Yes. If you worked with like a British system, you may have heard of the IGCSEs or GCSEs, and the A-levels or the IBs, right? And IGCSEs are like middle school level stuff. There is a computer science like course from them, usually in forms of books, and you can find PDFs online if you know where to look. A-levels and IB stuff, also this is high school level stuff, and they also have a computer science stuff. So the first thing I did was not even this actually. I went to YouTube and I went to, I think, PBS Ideas, and they had like very basic, very colorful, like 4 to 5 minute videos, and around 20 of them around computer science, and I just watched that. And after watching that, I went through the middle school stuff, and then I went through the high school stuff. And then after that, I could actually kind of read the university level stuff, right? And there's no shame in doing that. Like, you're completely new to this, you're just like basically a dog walking yourself. You have to start easy, right? Just remember how you started programming, and just take it one little step at a time, all right? And what topics? Computer science. So the more specific topics in computer science that I think are like really good bang for your buck is operating system, OS, databases, networks, compilers, algorithms, and data structures. I really hate them because we have to do the coding test, but it is actually kind of useful when we actually look at the applications of algorithms and data structures. And like lower level languages like C and C++. I don't like C, so I learned Rust. So anyway, and the why is we solve, I think, mainly 2 problems as software engineers. One of them is business problems, and the second are technical problems. And business problems, they end up just being CRUD. CRUD is create, read, update, delete, and really like the rules before actually like doing a update or like a delete or a create is very complicated, but you just end up doing the same thing over and over again. If you're a backend engineer, you just make a lot of CRUD APIs. And if you're a front-end engineer, you just make a lot of forms to input data. And that becomes like everyday stuff for you. But the other more interesting kind of problems are like problems of like, let's see, scalability. How much can you like scale your service out to a lot of different users, or like how much data can you like really receive and process at the same time? Like how fast that your page can load, or like how fast that your API can give back responses. So like speed, like latency, and fault tolerance. What causes faults, and like what can you do to prevent that service is up like 99.999% of the time. And this is kind of the more, I guess, like technical and like for me a bit more interesting kind of stuff that we can solve as engineers. And without the knowledge of computer science, this is unfortunately quite hard to solve, right? I'm not sure if we can show YouTube videos. Can we show YouTube videos?
Yeah, why not?
All right.
Oh, wait. How long? I actually don't know.
Okay, so the example video I have here is called How I Made JavaScript Blazingly Fast. And this is by a front-end engineer from he works at Netflix. And he found out that after like trying to make like rendering and all that kind of like front-end stuff as fast as possible, the last thing that he could really do was like looking into how memory management works in like Node.js and how garbage collection works. If you don't know these things, and like there is no way of solving this kind of problem, and like stuff like memory and like garbage collection, all that kind of like memory allocation stuff, that is like computer science topics. And I learned these things, and you can learn these things too. It's not magic. It seems like magic, but it's not, right? And yeah. So besides books, right? There are other ways to learn this. Is networking people, stuff like this. Come to Code Soul. We do lots of workshops. And other thing is study groups. I personally did a lot of study group stuff with people at my previous job. We learned about architecture patterns. We learned Rust, and we just like learned a bunch of things together. And we end up just like having accountability and doing stuff together. It just really motivates you to learn a lot really fast, right? So if you're worried that this is like so much stuff to learn and all that kind of stuff, don't worry. When you get the job, you will find yourself just learning all of this kind of stuff just really, really fast. It just kind of happens because you're doing this 8 hours a day with a lot of other devs working at a very high level. So just don't worry if this seems like too much. Just like it's okay to slow down, and I should also slow down. All right. So one topic for backend engineers that I want to cover are databases, right? you're most likely going to work with a relational database at some point, and there are a lot more NoSQL databases popping up for like Redis and MongoDB and blah 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 whatever. But the relational database is going to be like the majority of like the persistence, like a persistence way that a web application is going to use, or anything will use. So yeah, I'll learn SQL and learn to think in tables. So what learn SQL means is like just learn how to select, learn how to insert, learn how to update, delete, learn how to define tables and rows and all that kind of stuff. And then thinking in tables, when I do Python and when I do SQL, I have to think very, very differently. In Python, I have to like think very like imperatively, like do this, very, very specifically. But in SQL, I have to work very like declaratively, like select this by doing this, that, and that. And like I have to think how things are organized in tables rather than like in single individual variables. And that can be like quite a big shift from like programming normally. And that is so it can be like a big change for you. So like, but if you push through, it will be very, 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 very valuable. Because as backend engineers, we're gonna be working with a lot of ORMs. Rarely do we really work with like raw SQL, like querying data or inserting things. So like, because that can be prone to error and it can be like a security problem. So a lot of like engineers have made like ORMs, like object relational mappers, where a object and its like properties are mapped onto a table exactly in the database. And these abstraction layers over the database can be really, really useful, but you can't fully trust them, right? You'll be writing like complex queries using the ORM, and when you actually try to run the code, it doesn't run as expected, because you don't fully understand the ORM. So you will write like faulty SQL through the ORM. So if you know SQL, right, you can use the ORM to first write the query, and then compile the query, and then see for yourself if the query is working as expected and doing exactly what you need it to do. But if you don't know SQL and you trust the ORM blindly, you will be in a world of pain, because the ORM will be doing weird stuff that you don't want it to do, right? I could go a bit more about the ORM, but I'll go into other stuff. Another like basic thing that you can do with like databases is using indexes. So when a database like filters for things, it can search for things like one at a time, which is very inefficient. But if you use an index, if you apply an index to a column, what it does is it organizes the data into like a balanced tree. Correct me if I'm wrong, but it's some sort of tree data structure. And when a database like searches through a tree instead of like a single like column, the time reduces from O of n to O of log n. And O of n is called like a time complexity, and time complexity is like the worst case like possible scenario of worst case possible like time taken for an algorithm to run. So like any process. So if there are n rows, the worst case would be it's gonna search for n rows to find the thing. Like if there's 100 rows, it will search through all 100 rows until it finds a thing, right? So the time it takes to search for what you need to search can go from like n to a log of n, and log of n is like in math terms like much smaller than n. And this is like, again, the computer science stuff that I hope people know and that people will get to learn. So yeah, like, and with these things, you can reliably write code that will do what you need it to do, and like write code that will just go, hopefully just blazingly fast, because slow queries just really mess things up. Okay.
And we also have 2 presentations on database stuff, which you can check out too.
Oh, I couldn't find the link. Okay.
I just shared it.
Okay, nice. All right. The next is browsers. I am not a front-end dev, so I have no idea. But if I were a front-end dev, I would probably learn how the browser like renders our code, the HTML, CSS, JS, how it really works under the hood, and I will learn how the V8 engine works. I think that's the engine that Node.js uses to compile JavaScript into C++ and runs it to make it go really fast. And I'll probably learn just enough C++ to just learn how the compiled code works. This is another example by a YouTuber that I found, and it just really explains how the weird complexity. It explains like the weird like JavaScript complexities that can happen with like dates. So how it gets compiled into C++ and what the C++ code actually does. And as a JavaScript dev in the front end, I think you should definitely like learn really what goes under the hood. So the commonality between like the DB and the browser stuff is like don't fully trust auto compilation. You don't know the devs, you don't know how they were thinking, so they may end up working slightly different than how you actually want it to do. So yeah, just there are layers of abstraction over a lot of things to make life easier. So, but it does make life easier, but it just hides a lot of things from us. So you should really just be constantly questioning the technologies you use and just really trying to learn more, right? That's how you can, that's a way of becoming a better developer. So honorable mentions, I don't know too much about this stuff, so I just kind of like scrunch them up here. So network and OS, I am trying to slowly learn this kind of stuff because really this is, I think, possibly even more important than I think database stuff, because as like generally in web applications, we do a lot of communications between front end and back end through the network, and we can't just normally just blindly trust that it's going to be fine all the time. And if you do that, when things go wrong, you'll have no idea how to fix it, right? You looked at the DB is fine. You looked at the code is fine. The business logic is fine. And then it's a network problem, but you don't know what the network is, then you're kind of screwed. You have to ask someone else to fix it or whatever, or you just can't fix it. And the operating system, that's where our code runs. We have to, so I mean, since that's where the code runs, I think it's worth learning how the operating system allocates memory to run the code, and like and how the RAM works, and like how the CPU works and all that kind of stuff. Because when I got a little bit into DevOps to know what's going on when we push code into servers, I started hearing stuff about memory leaks and like servers suddenly going down. And I honestly have no idea why that happens sometimes. So if I knew more about the OS, I could probably like figure out what's going wrong, and I can probably fix it, because a server going down means like potentially a lot of loss of money to the business. And if the business does not do well, then you will get the cut, right? And the next is security and privacy. The security thing, both very important things, two very important things that I know nothing about, but thankfully CodeSoul did a workshop on security, so please have a look. This is like really sensitive stuff that can really just tank your company, or just have lawyers and policemen coming over to you and just like, hey, you broke the law, so you're going to jail. And that's not really nice, right? At the first company I worked in, we put in basically a lot of sensitive personal information in Google Sheets. Yes. And and one of the users said, hey, I don't want to use this app anymore. Please stop contacting me. And then we basically contacted them again, because people make mistakes. They don't really delete everything in Google Sheets. And the like Korean Internet Committee or something, they came knocking to us and said, hey, you broke the law. I don't care what you have to say. You'll pay a fine. And you're on your second strike. And on the third strike, you will not be able to do business anymore. So yeah, it is really scary. They have really like black and white thinking, and just, if they say you're screwed, then you are definitely screwed. And like the punishment can even go even worse, right? So you could be sued and you could get like a criminal record. So it's like really important stuff. The next is logging. So let's say logging to me is just recording all the requests and responses that a server or client would get. So a server would get a request to API 1. The payload is X and the response was Y, and the status code was 200. it would log all of this information in rows in a table somewhere, and this is useful to know when something goes wrong in like development or stage or production servers, right? When things go wrong, you need to gather a lot of information as quickly as possible so they can actually fix it. And if you do this manually through like a QA telling you that there's a problem, or just like you suddenly encountering this, it is very time consuming to go through this just manually. You all know about just like inspect element. You go through it. You actually make the request through the client side. You see the network response. You copy and paste the payload and the API and all that. Try and recreate it. Blah blah blah. You don't have to do all that. And some logging services do this job really really well. They show you the exact line of code that caused the error. They show all of the payload that the client was sending, and they show you the status code response that the server was sending, and it just really really saves you a lot of time. So if there's no logging, really push at your company to implement logging. I had no idea really what it really did or what value it brought, but when I actually started using it, it was like a whole new world. It's like we have like a fully fledged like expert QA team that communicates extremely well. So yeah. And finally is that breaking into tech can be very difficult. I know it myself. I got lucky and I got hired, so I can't really give any advice, but I just want to say that there are other, I guess, options in tech that I found. So next slide. So yeah, there are many ways to get into tech, and I think you can use these options as like a jumping off point, or you can consider them if you don't like being a software engineer anymore and like want to look at different options, right? These are the things I found, like developer relations, sales engineer, security analyst, blah, 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 blah. And these are not exactly, I think, software engineering roles where you like write a lot of code like we do, but it's like tech adjacent and more specialized at some points. Developer relations, I think, is like software engineering and marketing put together. Sales engineer is software engineering and sales put together. And all this other kind of stuff, security, self-explanatory about like security, network about networks. Cloud architects, there's a lot of like cloud architect jobs in AWS. You need to know a lot about AWS cloud so you can help people set up their AWS stuff. DBA, database admin, really specializing in DB stuff, and data analyst and data scientist. They write code and do like statistical analysis kind of stuff, but they're not really writing like software engineer code. And finally, like sysadmin, also very technology adjacent, but not really software engineering. And all these kind of like specialized, slightly different roles, they require technical skills, but I don't think it requires like the level that a software engineer needs, right? Or you're in software engineering and you find these roles more attractive because you like talking to people more. You can do like developer relations or sales engineer, or you like security more, network more, DB stuff more. You can transition. So like career doesn't have to be like, I think, a really one-way street. You know, you can like hop back and forth if you really need to, right? And even still, you can just like completely leave the software engineering stuff behind and become a PM like Beach. Yeah, and
I wish I could leave it behind.
yeah. And finally, the final point that I want to make is that in the end, it's just a job. Yeah. There's a guy saying, no, you have to sacrifice everything for your company. And you will say, no, I will not, right? Because in the end, it's really just a job. These companies, they exist to make a profit. Always remember that. You are a cost. You're a cost generator, or at the same time, you're also like a revenue generator, right? What these companies see at the really high level, it's just like, plus minus stuff on their balance sheet, right? And it's just never really forget that. The people around you will be nice and all that kind of stuff, but really, all they really care about is money, and that's just how companies work. All right, and this is like a pro tip for talking to like non-tech people. They will not understand tech, but they will understand money. Yeah. So talk in terms of stuff like, let's say my hourly rate as an engineer is like $20 an hour, and I have to spend like 50 hours doing this feature, and that's going to be like, I think, $1,000 no, I can't. Wait, that's $1,000. And this feature could potentially bring in 20K worth of revenue to the company. That's going to be like a worthwhile investment in terms of the company to make me develop this. But if it turns out that whatever thing I'm doing, this 1,000 hours of work, $1,000 worth of work, brings in only like $10 or $500, it is really not worth to the company. So whatever work you're doing, think about like how much like money you're actually bringing in. And when you say, hey, I don't want to do this because you don't want to do this, use that as a reason. Use money as a reason. And when you want to do something, use like cost saving as a reason as well, because companies really like cutting costs. They don't really like hiring people. They don't really like spending a lot of money on the infra stuff. So if you can find ways to like cut infra costs, like infrastructure, like cloud infrastructure costs, or like people costs, talk in terms of stuff like that, right? And third is politics. Politics is, you can't escape it, even if you're a software engineer. And that's going to be more and more apparent as you progress through your career and become more senior. And unfortunately, you will probably have to do some people management at some point, whether you like it or not. And politics is tiring, and it's just going to happen. Just accept it. That is going to happen. And like the four final points is just me trying to say, eventually there's going to be stuff to you that's going to be more important than tech and your job. You may start a family. You will get a job. You may start a family, get children. You may just have health issues. Like someone in your family may get really sick, all that kind of stuff. And in that case, I think you should really just suggest, following your heart, just quit the job, whatever. Like families can be more important. Just if the job is just really so shit that your health is declining, just quit the job, do what you want, and just, I think tech really is like a young person's job, because you have to be constantly learning and just like constantly aware and just like really like on top of the game to really progress. If you coast, it's kind of like, I think it's kind of a career killer. So like eventually like this point it will come to you as well. So have that in mind as you're trying to get a software engineering job, or you just got your software engineering job. So yeah, this is the stuff we covered, productivity, bang for your buck topics, the computer science stuff, what to learn, how to learn them, and in the end it's just a job. Just always remember that. Have perspective. And these are the specific things that I read and the specific YouTube channels that I watched that I gained a lot of value from. The low-level stuff is the first book. Yeah, Code, the Hidden Language of Computer Hardware and Software. It shows you how a computer is built from like binary logic gates, from like 0-1 kind of stuff to CPUs, memory, like hard disk and RAM and all that kind of stuff. It really just goes through step by step, and you end up getting like a good overview of how a computer is in your head. And like software design, architecture patterns with Python, I think that was the single most impactful book in my career so far, in my short career. I really learned that, wow, all the code that I've been writing is absolute utter dog shit, and I should do everything all over again. Yes. And finally, learning domain-driven design is a more expansion into the domain-driven design topics that is introduced in architecture patterns with Python. And for databases, use the index loop. It is a free book online that just tells you just enough like database stuff to get you more productive with working with databases, and just like make it that could work as a jumping off point for you to learn more about database stuff, right? And languages like Fluent Python. I work with Python mainly, and I've been mostly working with like kind of basic stuff. But when I read Fluent Python, I could really find myself just working with more like difficult, weirder things that made me just a better Python developer. And for like the low-level stuff is Rust. C. If you try to learn C after work when you're tired, you won't learn anything, because C is such a bitch. Just like manual memory management, you just want to kill yourself, right? Just learn Rust. Like Rust makes memory management and memory allocation, all that kind of like low-level stuff, much more bearable, right? And the YouTube channel are these things. Primogen, front-end guy, but very insightful, even as a back-end person. Arch and Codes, works with Python and design patterns. useful in your day-to-day jobs. Code opinion, he works with software architecture, mostly in the C# space, but like the tech stack doesn't matter. Like the architecture can be applied to any language across any like levels of work. He gives a lot of practical, solid advice. And Hussein Nasser, he's also a backend guy, but he really goes deep into like databases and network stuff. Yeah, I learned a lot from all these people. And yeah, that's it. That's it. Thank you.
So questions and discussion. Anyone have any questions?
Oh man, I talk so much. Holy shit.
Burn yourself out. Huh?
Yeah. Oh god.
That's why slowing down helps.
Yeah. No questions, thankfully. Oh.
Is anyone actively searching for their first developer job? One. Is anyone in their first developer job right now? Two. Was. Escaped the first job. What are there any specific questions that you folks have? Or like any experiences that you want to share that maybe Jason didn't touch on?
Please go ahead. God damn it. Please go. No, I
Dude, don't worry about it. It's
yeah,
fine.
please go ahead. Just
You only needed it so if you're walking around.
Yeah, what's up?
I do have a comment, like, most of the things that you mentioned actually applies to, like, other types of jobs in law.
it does. Yes.
Yeah, because I worked as a customer support, and then I work closely with developers, QA, but also logistics, marketing, sales. All of those things are actually applicable in this all disciplines.
Yeah, because it literally is just a job, you know.
Yeah.
Yeah, you just happen to be working with tech.
Yeah.
Yeah.
Especially being nice.
Yes. Yes.
But I think they were the nicest though at my company, the development team. But the sales one, really sneaky.
Yeah.
That's nice. Sales and business development.
Yeah.
Very
So they
sneaky.
have to sell, so usually the way they talk, they
Yeah. They work in lies.
Other comments, questions, suggestions?
Well, okay, I had a question. So I came in a little late, and I think I came here just to like get a wider perspective of just I guess different aspects of the tech industry. And so when you're going through like more close to the last slides, I realized like my category is very different from software engineering. So I've been kind of focusing on data science and data analysts. And so I'm wondering from most of what you say, like would a lot of that be like your experiences and your stories, would they be like crossover applicable to what I would do or the mindset I would have in those fields as well?
I would say besides the technical stuff, it's universally applicable. I've been only working as a software engineer for like 1 year officially, but I've been working like 4 years overall, and like 6 years if I count the military service. And like all the lessons I learned about people and like communication and all that stuff, I think is really just universal. Yeah.
So data, I'm only using the mic because we need the mic to pick up the stream. So the question was like, and I'll repeat the question for the benefit of the stream and recording. So the question was like, hey, if I'm doing something, adjacent to software engineering, like data science, data analysis, that kind of thing, how much of this is applicable? Is that right?
Yeah, that's kind of just it.
So I want to add a little bit, like, with software engineering, there's a big focus on like reusability and readability and all that kind of stuff. But with things like data science, like you write the report once, and then you generate the report, and then it's done, right? A lot of the time. But at least like with some of the data scientists I work with, they end up kind of figuring out like, okay, I use this logic very frequently, so maybe let me just grab that in a function, and then I can make like a little library that I can reuse, right? And then maybe I can share that with my team. And then you can write tests for that, like he was saying too. Now that's a little harder to apply in data science because that's more of like the art side of it, like knowing like, having experience of, this kind of thing is going to be used often, or I anticipate the customers going to ask for this again, that kind of stuff. So yeah, I guess just a little technical bit I wanted to add on, because I did a bunch of data analysis in the past. So.
Okay.
Does that make sense?
So, I mean, I'm curious. I know I've seen you, so a few weeks ago, I went to the, what was it, Careers in Tech seminar that was here.
Mm-hmm.
And I remember, yeah, you were kind of you and the lady and then mainly the cybersecurity one.
Mm-hmm.
And so, like, what exactly, well, could you tell me, like, what is your work, like, your current, or your experience, I guess? What is your experiences so far in tech? Like, have you gone from just, like, entry-level software engineering to different, like, aspects of it? Like, I don't know, working as a cloud architect, network engineering, something like that?
Mm-hmm.
Or has it just been one specific field you stayed in?
Oh, I jumped around. So the question is like, what is, as an example, what is kind of a common path, or what was the path that you went through to like get to, yeah. So my first job was, so first off, I went to school for like video game design and development. So I learned like game design, a little bit of art, a lot of software, all this kind of stuff. But then my first job was operations at a cell phone insurance company, which is like the opposite. So I was doing like, you know, basically keeping the servers running, right? If a server goes down, do we know about it? Who fixes it? This kind of stuff. So that was my first job. And then because it was monitoring stuff, basically, that transitioned into kind of back then it was called ETL operations. So when we do data exchange between us and other customers and things like that, how do we make sure that the data transfer worked properly? How do we make sure that, you know, if there's missing a file, do we know that we missed a file? How do we tell the customer to send us that file, all this kind of stuff. Then from there, I transitioned into data analysis. So no statistics, I have zero statistics knowledge, but it was more like, hey, can we do all these aggregations over this data set? How can you reorganize the database to make these queries faster? How can we show this stuff in real time, this kind of stuff? So kind of like a cross between monitoring and data analysis. Then I went into data engineering, which is more of like moving the data around. Then back-end engineering, and now I'm a PM. So like, just because you end up getting into one of these areas, like, you can certainly switch. And like, there's always something that's quite adjacent that you just expand your skill set in some direction, and all of a sudden you're that thing. And that's totally viable. And like, I did that like, what, 5 times? I wasn't counting, but you can definitely move around. Does that answer your question? Or?
Yes, I do. Oh, I have one thing. I guess this is for both of you. This is just kind of just a free question, just in the back of my mind. So recently, I'm working a lot, mainly with my Jupyter notebook, with just like TensorFlow and different things related to neural networking. And I was kind of thinking, like, you're kind of going off what you said about like how you can, in this tech field, you can start off in one area and then 5 years later be in a different area. And I was wondering, like, maybe I should like educate myself or diverse in terms of like another language. Like, in addition to this specifically, I guess, neural network languages, should I pick up like more specific Python training, or should I try to get more specialized in C? And so for you guys, is there one or two like specific languages that you would say that have like as close to a universal use as possible? Like, if I was to go from neural networking, but then let's say I want to go into something more like what you do, where I'm working more with a lot of code architecture.
So the question was like, hey, if I'm specialized in this one area, but I want to kind of diversify, what is some kind of common skill or common technology I can learn to make myself more flexible? Is that accurate?
Yeah.
Okay. You want to go first?
My opinion would be either Python or TypeScript. I think possibly, like, those are like general purpose, very popular languages that have a lot of applications, like here and there. They're like relatively easy to learn, to pick up. So possibly those two, but I would say do what interests you, do what motivates you more. These are my opinions as like a software engineer, but like what you may be interested in actually could be different. So yeah.
So from my side, people are going to hate me when they hear this. Yeah. So I think like Java itself is very popular in more traditional industries, which is not necessarily where you want to work, but it does teach a lot of good software architecture because it's strictly object-oriented, which has its advantages and disadvantages, and it's kind of starting to fall out of vogue a little bit. but it shows you how to think in terms of flexibility, how to think in terms of reusability, how to think in terms of like manageable code. But again, that's more on the software engineering side. If you're more interested in other spaces, like, yeah, does that answer your question?
Yes, perfect.
Others?
We're done.
I got a question. Who's hungry?
I'm famished.
All right. So let's go ahead and end the stream. So thank you, Jason, for the wonderful presentation.
Thank you. Thank you.
And thank you everyone for coming. Let's go ahead and grab some food and relax for a bit. And bye bye YouTube.